recall that to solve an ordinary differential equation means to find all its solutions. And there are usually infinitely many. But sometimes we just need one solution. So an example of, is from our first modeling example, right? So if we have an object such as a cat who jumped out of a balcony on the 9th floor and then is falling down according to this law, basically what we want to find is not to solve all possible solutions, but we just want to find the solution for this particular cat. So which means that initially, since it just fell down, initially its speed was 0, but then we just need to write down the equation for v of t and to see that, you know, the terminal speed when it reaches the ground, is it going to exceed, is it going to be slow enough for the cat to survive, or is going to kill the animal? And that's what is called an initial value problem, which means that we have the differential equation describing our the process that is going on, and we have the initial condition. So we know the value of the unknown function only at a particular point, and then we need to find the value of the unknown function at all points v of t. Or if, say, we know that the population of a city grows according to the logistic equation, say, we believe that in Singapore, the population is governed by the logistic equation with the carrying capacity 7 million people. So we assume that, well, say the government of Singapore wants the population to eventually reach 7 million, right? So 7 million is here. And we know that in 1991, the population of Singapore is 3 million. So what is the population of Singapore going to be in 2050? Well, I mean, just some rough estimate. Of course, in reality, it probably does not really exactly follow the logistic differential equation. But if we don't know anything at all, then an educated guess based on the logistic differential equation is at least going to be to give us some reasonable estimate, right? So whether the population in 2050 is going to be closer to 3.5 million or to 7 million or to, I don't know, 6.5 million, and it is already important, you know, and so it's this is governed by this initial value problem. Right? So an initial value problem consists of a specific ordinary differential equation and an initial condition. So geometrically, the initial condition tells us that it is a point on the plane ty. So we know that our solution passes through this specific point. And so, for example, here is our initial value problem. It consists of an ordinary differential equation, ODE, and the initial condition, right? So initial condition. And then we can verify that this function is a solution of this initial value problem. So we need to first verify that it satisfies the differential equation, and second, we need to verify that it satisfies the initial condition. Okay? Well, then again, how to solve an initial value problem is the topic of the next lecture. But now it's just the concept and how